5.7. This is the last section in chapter 5. So that means a test is probably coming up over chapter 5. Probably next week. More specifically, probably Thursday of next week.
Why not Friday?
Because we won't be here Friday. Exactly.
Friday's a better day.
So, systems of linear inequalities. That's the section today. Like I said earlier, what we did yesterday, graphing the linear inequalities, will help us out with today's lesson. So let's graph some systems of linear inequalities. A system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown below. So you guys remember the systems of equations we talked about for forever? Kind of the same idea, it's just inequalities this time instead of equations. Y is less than x plus 2. Y is greater than or equal to 2x minus 1. Two inequalities there, got the same variables. It's a system of linear inequalities. A solution of a system of linear inequalities in two variables is an ordered pair. That is a solution of each inequality in the system. So once again, very similarly to our systems of equations, for an ordered pair to be a solution to my system, it must be a solution to both inequalities at the same time. Does that make sense? If it's a solution of one but not the other, it's not a solution to my system as a whole. Okay? It's got to make both inequalities true when I plug it in. I'm not going to spend a whole lot of time on our definitions here. If you want the rest of the definitions, they are in the book. Or you can go look at Canvas later at the notes, but let's go ahead and move on. We've had an example like this on when we talked about systems of equations, when we talked about inequalities yesterday. We got one similar to it with our systems of inequalities. Tell whether each ordered pair is a solution of the system of linear inequalities. Do what? So our system is y is less than 2x and y is greater than or equal to x plus 1. First ordered pair it wants me to check is 3, 5. So what do I need to do with that?
Plug it in.
Plug what in where?
The 3 to the x.
Very good. Starting with inequality 1, we're going to plug 5 in for y and 3 in for x. Just like that. Everyone okay with how I've plugged in? We're now going to work down both sides of the inequality. If I get a true statement, that means that that ordered pair is a solution of that inequality. If I get a false statement, it's not a solution of the inequality. 2 times 3? 6. 5 is less than 6. Is that a true or false statement? True. So I know that that ordered pair, 3, 5, is a solution of my first inequality. Does that automatically make it a solution to my system as a whole? No. No. So what do I need to do? I got to check the second one still. Once again, what am I replacing y with? 5. What am I replacing x with? 3. And then I work it out both sides of the inequality. What's 3 plus 1?
4.
4. 5 is greater than or equal to 4. Is that true or false?
No.
True. 5 is greater than or equal to 4. So, it's a solution to both of my inequalities. So what would you say about the ordered pair being a solution or not a solution for the whole system?
It is a solution.
It is a solution because it works for both inequalities. So I'd say 3, 5 is a solution. Any questions on letter A here? Does that make sense? We've dealt with this before, just a little different because we have our inequalities. Can I move on to B? All right. Same system of inequalities, different ordered pair, negative 2, 0. Same concept, right? Just going to plug the x value in for x, the y value in for y. So what's being plugged in for y here? 0.
And then it's negative 2?
Negative 2 in for x. Very good. What is 2 times negative 2? Negative 4. 0 is less than negative 4. Is that a true or false statement?
True.
It is false. 0 is not less than negative 4. So do I even need to check the second inequality at this point?
No.
No. It's already not a solution to my first inequality, so I know that that automatically means it's not a solution to my system as a whole. So I would say negative 2, 0 is not a solution. Once again, do I want you to say no solution? No, because there very well could be a solution. We're saying this specific ordered pair is not one of my solutions. Does that make sense?
Yeah.
Questions on A or B?
No.
All right, let's move on. You don't necessarily have to write this down. This is just a blanket statement. The graph of a system of linear inequalities is the graph of all the solutions of the system. So our graph helps us represent all the solutions to our system of inequalities. Just like yesterday, the graph of our inequality represented all the solutions of that one inequality. The graph of a line represents all the solutions of a linear equation. Graphs help us represent and visualize all the solutions for our inequalities or equations. Okay? Write these steps down. There's 2 steps here. Step 1, graph each inequality in the same coordinate plane. Kind of like how we solve systems of equations by graphing. We graphed them on the same coordinate plane, right? So graph them just like we graphed each inequality yesterday. Graph your boundary line. Shade whatever side needs to be shaded. Step 2, find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. So I'm not looking for the intersection of the 2 lines. I'm looking for the intersection of the 2 shaded regions. Okay? So they give us an example here. Y is less than x plus 2. Y is greater than or equal to 2x minus 1. So let's look at this blue inequality here. Y is less than x plus 2. What's the y-intercept there? 2. What's the slope?
1.
Up 1, right 1, up 1, right 1. That's how they got their boundary line. Just graphing like we did yesterday. Line or no line underneath my symbol?
Line.
Is there no line? So what kind of line is it? It's a dashed line. That's why it's dashed here. Okay? And then it says y is less than x plus 2. Would less than be shading above or below the line? Below. So that's what this blue shaded area represents, is the solutions to this inequality right here. Okay? This line down. And then they graph their second inequality on the same coordinate plane. What's the y-intercept here? What's the y-intercept?
-1.
Negative 1. What's the slope?
2x.
2 over 1, right? Up 2, right 1. Once again, this is how they got this boundary line. Down 2, left 1. Does it have a line under it?
Yeah.
Yeah, so does it need to be dashed or solid?
Solid.
Solid, there it is right there. Y is greater than or equal to 2x minus 1. Would greater than be above or below the line? Above. So that's why this, it's shaded above this red line, this pink area. Okay? Now if you notice, we got the red or the pink and the blue going this way. Where they overlap, it's kind of purple, isn't it? That little section is my solution to my system of equations or inequalities. That little wedge in there is my solution. Not this over here. These ordered pairs are solutions to this inequality. Not this section over here. These are solutions to this inequality. I want the overlapped shaded area. Does everyone see how they overlap each other, and that's my solution? Okay? Any questions on that? So if you're going to shade it like this, I'm going to show you a different way to shade here in a second. If you shade it like this, where you shade below this line and above this line, just make sure that the overlap is darker so I know that you know where the actual solutions are. Okay? Can I move on to some examples? Okay. Graph the system of linear inequalities. Are these already in slope-intercept form for me? Yes, they are.
Wait, no?
Yeah, they are.
Oh, yes, they are.
Y is less than or equal to 3. How would I graph that?
Why is 1, right?
That's not my slope, is it?
It would be
The slope is what? 0. So what kind of line is this going to be? Horizontal line, right? This is hoi. So which axis is it crossing? The y-axis. Where is it crossing it? 3. So I'm going to put a point at 3 on my y-axis. What do the H on hoi stand for? Horizontal. Does my inequality symbol have a line or no line? Line. So what kind of line does this need to be? Solid horizontal line through this point. What I like to do when I'm graphing a system of linear inequalities, I like to draw my boundary lines first, both of them, and then I do my shading. Okay? So is everyone okay if I jump down and graph my second boundary line? Okay, what's my y-intercept here? 2. What's my slope? 1 over 1, right? Up 1, right 1. Get as many points as you can fit on that graph. What other 2 directions can I go? Down 1, left 1. Is there a line or no line underneath my symbol? No line. So solid or dashed? Dashed. There's my 2 boundary lines. Is everyone okay with that? Okay. Does everyone see how our boundary lines form 4 sections on our graph? There's this section here. Hold that thought. We've got this section here. We've got this bigger section up top here. We've got this section here. And then this section here. So everyone see how that's 4 sections? Okay. We're only going to be shading one of those 4 sections with the way that I'm going to show you how to shade right here. Okay? So let's look at our horizontal line here. Y is less than or equal to 3. If it's less than, would I be shading above or below the line?
Below.
Below. So would I be shading any section above that line?
No.
No. So what I'm going to do is eliminate those 2 sections above that line. I know I'm not shading either 2 of those. Either one of those. Does that make sense? Okay, now I need to look at the other line. Y is greater than x plus 2. Is greater than, would that be shading above or below this line?
Above.
Above. So would I be shading anything below it? No, so I can eliminate both sections below it. That one's already eliminated, but I can eliminate this other one below it. Do I have a section left? Yeah, that's my solution. Any questions or confusion on that, on eliminating sections? We okay with that? It just helps you shade less. Okay? But that would be the overlap between my 2 shaded regions. So all these ordered pairs in this shaded region are solutions to this system of inequalities. Would ordered pairs right here on this line, on this dashed line next to the shaded region be solutions or no? No, because it's a dashed line, right? What about ordered pairs on this solid line next to the shaded region? Yes, because it's a solid line. Those are included. What about the point of intersection right here of our 2 lines? You think that's a solution? We do? Because it's on a solid line, but it's also on a dashed line. That one is not a solution, actually, because of that dashed line. If they were both solid, that point would be a solution. Okay? But after I do that, I'm done with the graph. That's my answer. I can move on. Are there any questions on example 2? We good? Can I move on? Sure. Graph the system of linear inequalities. Example 3. 2x plus y is less than -1. 2x plus y is greater than 3. Are these inequalities in slope-intercept form?
No.
No. So before I graph, what do you think I probably need to do? Yeah, put them in slope-intercept form, solve them for y. What would be my one step on both of these to solve these for y? Subtract 2x from both sides, right? So for inequality 1, I'd get negative 2x minus 1 on the right. Would my symbol flip or stay?
Stay.
Stay. For the second inequality, I'd get negative 2x plus 3. Symbol flip or stay? Stay. Are those now slope-intercept form?
Yes.
Yeah, they are. Y is by itself. The x value and the constant are on the same side of the inequality. So now we can graph them. First inequality, what's my y-intercept? Negative 1, so put a point at negative 1 on your y-axis. What's my slope?
Negative 2 over 1.
Down 2, right 1. Can also go up 2, left 1. And solid or dashed line? Dashed. There's no line underneath my inequality symbol, so I know it's dashed. You okay with that first boundary line? Okay, second inequality, what's my y-intercept? Positive 3. What is my slope? Negative 2 again, negative 2 over 1, down 2, right 1. What kind of lines are these going to form? Parallel. What was our answer whenever we were solving systems of equations and we got parallel lines? No solution. Because we were looking for the intersection point, right? And they would never intersect. Solid or dashed line? Dashed. Do you think it's going to be automatically no solution if I get parallel lines with inequalities? You think so? Why do you think it's going to automatically be no solution?
Because there's no way for them to be anything else. They're parallel.
Yeah, there is. Because are we looking for the intersection point of the lines
Yeah.
for inequalities? We're looking for the intersection point of the shaded regions, right? Oh, yeah, there we go. So, is it automatically going to be no solution? No, it could be, but not always. Okay, let's check this out real quick. Let's look at our first inequality. This one going through negative 1 on the y-axis. It says y is less than negative 2x minus 1. So would less than be above or below my line? Below. So would I shade either region above it? No. Real quick, how many sections of the graph do I have here from my boundary lines?
3.
Just 3, not 4, right? This big section below this line, the section between the lines, the big section above this line. Back to what I was saying. We're shading below, so would I shade anything above it? No, so I can eliminate that section between the lines and the big section at the top. Okay, the line going through 3 on the y-axis. Y is greater than negative 2x plus 3. Would I be shading above or below that line? Above, would I shade anything below it? No. Do I have any sections left? No. So, what is it in this case? It is no solution in this case. But I don't want you to automatically think no solution when we're talking about inequalities and we get parallel lines. Okay? Does everyone understand why this one is no solution? Can I erase some stuff on here and show you something using these same 2 lines? All right, let's say Both my inequality symbols were both less than. Y is less than negative 2x minus 1. I'd be shading above or below? Below this line. So I wouldn't shade anything above it. Right? This one right here, y is less than negative 2x plus 3. Would I be shading above or below this line? Below. So I wouldn't shade anything above it, would I?
No.
So I only got one section left here. That'd be this big section right here. That'd be my solution. So does everyone see that we can get a solution if they are parallel lines? It's the overlap of the shaded regions, not the lines. Okay? Okay, one more thing real quick on this slide. Let's say this one was greater than, this one was less than. Okay, looking at this one again. Y is greater than negative 2x minus 1. Would that be above or below this line? Above, so would I shade anything below it? No. This one, y is less than negative 2x plus 3. Above or below the line? Below, would I shade anything above? No. What section is left? The middle section. So those ordered pairs would be my solution. I'm just trying to do all of this to show you that you can get a solution if your lines are parallel. It's not an automatic no solution. Does that make sense? Any questions or confusion on that? Now, systems of equations. Parallel lines are an automatic no solution because they will never intersect, and we're looking for the intersection point of the lines for those problems. These, we're looking for the overlap of the shaded region. Okay? Questions, comments, concerns? Can I move on? 2 more examples.
Oh, Lord.
It's all right. These are pretty easy. They go pretty quick, I think. We're working backwards here. Now it gives us a graph, and it wants us to write the system of inequalities from the graph. So instead of us graphing it ourselves, we're writing the system of inequalities. Say it again. Oh, you're going to say one for me?
Yeah.
Go for it.
Negative 2. I mean, like, the y is negative 2.
So what would the inequality look like?
0, negative 2.
We're not looking for the ordered pair. We're trying to write the inequality that's making this graph. So instead of being given the inequality and graphing it, it gives us the graph, and it wants us to write the inequality. Does that make sense? So we're going backwards from what we just did on the past few examples. Okay? So you guys want to start with the dashed line or the solid line? Solid? That's HOI. It's a horizontal line, right? So I know one side of my inequality will be y. The other side will just be some number. Which number is it going through on the y-axis? Negative 2. So that's going to be my number on the other side of the inequality. Okay? The shading is above this line. So would my symbol be greater than or less than? Greater than. It's a solid line. So do I need a line underneath my symbol or no? Yes. Am I done for that one? Yes, I am. Does everyone see how we got that? Did you pay attention?
I'm sorry.
I'll explain later.
Yeah, okay. I was too busy in this book.
Okay. Second inequality. This is my dashed line now. It's going to have a slope and a y-intercept because it's kind of slanted, isn't it? We're going to write these in slope-intercept form, so I know y is going to be on one side. What's my y-intercept of this line?
A positive. Oh.
Where's it crossing the y-axis?
0.
0. Do I need to put plus 0?
No.
No. I don't have to put that. What's my slope?
Oh, 1.
1 over 1 or just 1, right? So that's the number that's going to be in front of x. Do I need to put the 1 though?
No.
No. You can if you want. I wouldn't count it wrong. And then the shading is below my line. So would that be less than or greater than? Less than. Dash or solid? Dash, do I need a line? No. Here's my answer.
I don't like that.
Here's my answer.
Find out
Okay?
what it is.
Okay. Let's go back through it real quick. And I have another example like this, so we'll get another one. But let's go through this one again. For our solid line here, we know our inequality will be y and some number because it's horizontal, right? So I went ahead and put the y. I knew the number that it was going to be because I saw where it was crossing the y-axis. Where is it crossing the y-axis? -2. That's how I got the -2. Okay? Is the shading above or below this line?
I mean above.
Above, right?
Yeah.
Everyone sees that. So is above, does that represent greater than or less than? That's how I got my greater than symbol. Is it a solid or dash line? Solid. So do I need the line or no?
Yes.
Yeah. That's how I built that inequality. You guys okay with that one? Okay. The dashed line. It's got a slant to it, right? So I know there's going to be a slope and a y-intercept. What is the y-intercept? Where's it crossing the y-axis? 0. And I want these in slope-intercept form, so I already knew I was going to have y by itself over here. Do we need a plus 0? No. The slope is going to be multiplied by my x, so I put x down. I'm going to put the slope in front of it. What is the slope? 1 over 1, which is 1. So it'd be 1x. Do I need the 1 there, though? No. Shading. Is it above or below this line? Below. So would that be less than or greater than? Less than. Dash line. Line or no line? No line. That's how I built that one. Does that help? Okay. Let's do another example. Write a system of linear inequalities represented by the graph. You guys want to deal with the dashed or solid line first? Solid? Okay. Can anyone help me out with the solid line?
How do you figure out what sign it is if it's just...
We'll get to the sign in a little bit. Okay.
Why is it one greater than
Shouldn't it be like,
X is just 4, X is 3. And then
and then it'd be like,
X is 3.
well, I know, okay, it's 0.
X is 3.
So what?
X is 3.
Yeah, it's crossing my x-axis at 3. Right?
Wait, what?
Hold on.
I see.
This is a vertical line. Right? Hoy is y and a number. This is a vertical line, so it's vux. Vux is x and a number. Right? So I know I'm going to have x on one side. Wherever it's crossing the x-axis will be my number on the other side. So where is it crossing the x-axis? 3. We okay with that? Okay. We don't have an above and a below my line here, do we? Because it's a vertical line. We got a left and a right of the line, though. It's shading to the left of the line. So do you think left would be less than or greater than? Less than. Thinking about it like on a number line, right? Smaller numbers are to the left, so less than. Bigger numbers are to the right, greater than. So, what's my inequality symbol here? Less than or equal to, because it's a solid line. I got the 3 because this line is crossing the x-axis at 3.
Okay, we just did that blue.
2, 3, 4. Here's 3. It's crossing the x-axis at 3. Right? So, that first inequality is done. Right? That would be the inequality for my boundary line. Any questions on that first one? I feel like we're still confused. We good or no? Now's the time to ask questions. We need to clarify if we need to. You got questions, Mia?
No.
I think you do.
I don't know. I'm just kind of confused.
Okay. Should we do the next one and see if that helps?
Yeah.
Okay. The next one. Is it going to be a y and a number or an x and a number? Or is it going to have a y and an x? It's going to have a y and an x because it's got a slope, it's got a y-intercept. Right? Our dash line.
Oh.
Right? I know we want it in slope-intercept form, so I know y is going to be on the left all by itself. Okay? My constant, my number without the variable, is going to be my y-intercept. Where is it crossing the y-axis?
1.
Not 1.
What?
Oh.
The y-axis, where's it crossing? -1. Thank you.
Wait. So that black arrow right there, that's with the Y on top of it, you know that one right there? That don't count.
Say what? This?
Yeah.
Yeah, that's my y-axis. This dashed line is crossing the y-axis at -1. Because here's my origin, right?
Oh.
It went down 1. That's where it's crossing.
Oh, yeah.
-1. Okay? So we're good there.
You asked that one.
I know I'm going to have an x because it's got a slope. I'm going to put the slope directly in front of my x.
It's 1. Wait, is it 1?
I've got a point here. Got a point here. Got a point here. What would be my slope?
Up 1 over to the 3? No, I don't know. Up 2 over to the 3.
Up 2 over 3. So how would I represent that with a fraction?
3.
Wait, what?
2/3.
2/3. Rise over run.
Oh,
Well, 2 not 3, my bad.
2/3. Okay? Everyone okay with how I got the slope? This is chapter 3 stuff that we're doing right now. Finding the slope, finding the y-intercept from a graph. That's chapter 3 stuff. Okay? Now, is the shading above or below this line?
Above.
Above. It's on top of it, right? So would that be greater than or less than? Greater than.
Oh, why is it greater than?
Above is going to be greater than something. Right? Below would be less than something. Right?
Yeah, but I got something. Okay, so say if that line is going to the negative side, can we just say that's less than?
What do you mean?
So if the arrow is going this way, to like negative.
So let's say this line is kind of rotated like that.
Yeah. Would that be less than?
It depends on where the shaded region is at that point. Okay? Is this a dashed or solid line? Dashed. So do I need to put a line underneath my symbol or no? No. Okay. That was a lot more difficult than I thought it'd be for you guys. And I'm now done with the problem. Any questions or confusion on that I need to clarify right now? Whew. That was fun. Are there any questions so far about anything we've covered today?
I don't like this. So this test
I'm
that
sorry.
we got going on with, like when we do this test, that's gonna be on there?
Yeah, test will have it'll have solving systems of equations by graphing, by substitution, by elimination. It'll have some special solutions on there, systems of equations. It'll have graphing linear inequalities and graphing systems of linear inequalities. It'll have all that on there.
Do you figure out if it's greater than or equal to by like literally looking at like the line and the shaded area? Is that how you figure that out? Like if it's gonna
Yeah, so like this dash line, shaded region's above it.
So it'd be greater.
It's great. Right? Over here, shaded area is below this dash line. So that's less than. Yeah. Any other questions? How are we doing on time here? Plenty of time for the assignment, right? So, any questions here? Still feel like we're confused. Okay. We're going to get our assignment Monday over this. So are there any questions about my notes before I end the recording?